And, you know, we go back to Einstein. He had a lot of good ideas. And the question is there another idea? We think just as, you know, fission plants depend on E equals mc squared. If you look, though, at a different way of using E equals mc squared, which is to take a hint from Mother Nature, when you look out at the stars, every star you see is being powered by fusion power. That is nature's way of powering the universe. And so this is what we are interested in talking about tonight, and this is what I think the National Ignition Facility can bring to us in terms of developing this power. So let me remind you about what fusion power is. Unlike fission power, where you take large uranium atoms and split them into smaller atoms, which end up eventually as nuclear waste, the idea here is to take very simple atoms, two isotopes of hydrogen, deuterium and tritium, which means they have a different number of protons, and combine them together. And this is what the reaction looks like. You have a deuterium nucleus that has one proton up at the top, and a tritium nucleus down at the bottom, one neutron and two neutrons, and when they hit together, under high pressure and temperature, they fuse together and they form a helium nucleus and a neutron. So what you have left out of this reaction is a helium nucleus and a neutron. You don't have the long-lived byproducts of fission. And most of the energy is carried by that neutron. And so if you wanted to gather that energy up, what you would want to do is find a way of stopping those neutrons to heat a fluid and then use that heated fluid just like you do in a conventional power plant to drive a turbine.